Okay, so on today, we are going to be talking about proportionalities. I've already introduced this concept a few weeks ago when we did our acceleration lab, and today we're going to elaborate more on this. So, guys, again, if you do not have a sheet of paper, a pen, or a pencil, something to write with, please take that out right now because we are going to work on at least the first 10 together, and the remainder of the 10 you're going to finish on your own. Okay, so um, yeah, so that's what's in store for today. Okay, let me see. Also, as soon as you guys get done with this, um, you're gonna take a picture of it and you're gonna upload it to the submission box here that says understanding proportionalities. Okay, so you're gonna upload it to the submission box in order to receive credit. Okay, so that's the goal for today. Now, um, so a proportionality. What is a proportionality? So if you guys remember 2 weeks ago, I introduced two terms to you guys. I introduced the term direct proportionality, and I introduced the term inverse proportionality. Okay. And remember, we talked about that when we did this lab here. If you guys remember, the first thing we did, we figured out what is the relationship between acceleration and force. And so we have an object here, okay, and we clearly see that as I apply force on the object accelerates. Okay, so in this case, the acceleration is 1.38 meters per second squared. Okay. But guys, can someone tell me what happened to the acceleration as I increase my force? The acceleration does what? The acceleration gets larger, right? So guys, we call that the relationship between acceleration and force. We call that a direct proportionality, in that it's one increases, the other increases. Okay. So, okay. If I write out Newton's second law will look something like this. Acceleration is equal to force divided by an object's mass. Again, so if I was write out acceleration and rearrange this, write out Newton's second law, rearrange it to solve for acceleration, this is what I would get. Okay. Now, guys, in this class from now on, anytime I give you an equation and you see that you have a certain variable in the numerator of your equation, guys, it is always true that the numerator is directly proportional to the resultant of the equation. In this case, acceleration and force are directly proportional. Anytime I give you an equation and you look at the denominator, whatever variable's in the denominator, that is inversely proportional to the resultant. Okay, so whatever your equation equals to, these two variables are inversely proportional. Now, guys, remember that, because that is going to be an important thing we're going to talk about for the remainder of this year, because whenever we discuss equations from here on out, I'm going to ask you guys which two variables are directly proportional and which two variables are inversely proportional. So that is true for any equation, not just this equation, okay? And we clearly saw that acceleration in mass was inversely proportional, because we clearly saw that as we increased the mass of our object, so as we doubled the mass, we clearly saw that we halved the acceleration. The acceleration decreased. So just something to keep in mind. So acceleration and mass are inversely proportional, and we know that because mass is in the denominator. Okay, so force and acceleration are directly proportional, and then mass and acceleration are inversely proportional. Okay. So now, guys, here's what I need for you guys to write down. Okay. So, what does this? What does it mean whenever two variables are directly proportional? Well, what that means is that one variable increases, the other increases. As one variable decreases, the other decreases. Okay. So, for example, okay, consider this right here. Okay. So, we already know that, hold on, let me give myself some room here to write. So, as force goes up, then acceleration must go up. So as force increases, an object's acceleration increases. As force decreases, then the object's acceleration decreases. Okay. So this is what is known as a direct proportionality. Whenever two variables are directly proportional, as one goes up, the other goes up. As one goes down, the other goes down. So that's what I need for you guys to write down. That's what we mean when we say two variables are directly proportional. Okay. Now, what does it mean whenever two variables are inversely proportional? Well, whenever two variables are inversely proportional, as one increases, the other decreases. As one um, as one decreases, the other increases. So in other words, we just said that mass and acceleration were inversely proportional. And again, we proved that a few weeks ago with this lab. Okay. So I'll write that out here. So whenever two variables, such as mass and acceleration, whenever they're inversely proportional, what that means is that as mass increases, then acceleration decreases. Okay. But as mass decreases, then acceleration increases. Okay. So guys, go ahead and write that out. As mass decreases, then acceleration increases. Okay. Again, guys, we're gonna do the first 10 together. The remainder you're gonna do on your own. Okay. And by the way, let me just let you guys know that whenever we're working on our examples below, just so you're clear here, if you have a question that involves this situation right here, then that means we're going to multiply um, in order to get our answer. And the reason why we multiply is because, again, so acceleration is increasing. So in other words, as force doubles, acceleration has to double. As force triples, acceleration has to triple. As force quadruples, acceleration has to quadruple, and so on. So here we multiply. But in this situation right here, whenever we're decreasing our acceleration, we're going to be dividing. Again, I'm just writing this out so you guys know what to do whenever we get to working out these problems mathematically. Let me just put divide. Here now, in this situation right here, whenever we're increasing our mass and our acceleration is decreasing, in order for our acceleration to decrease, we need to divide here. And again, you guys will see what I mean in just a moment when I work out some examples. And here, whenever acceleration goes up, we're multiplying for this situation. So basically, in every situation where acceleration increases, you're going to multiply. And in every situation where acceleration decreases, you're going to divide. And again, in just a moment, you guys will see what I mean by that. Okay. So let's keep going. Number 3, if a particular variable appears in the denominator of an equation, is the variable directly proportional or inversely proportional to the resultant variable of the equation? What we just said is if it appears in the denominator, the answer to that is it is inversely proportional. So write that out for number 3. Again, guys, be sure you're writing along with me because whenever you guys upload this into Schoology, I'm going to make sure that you guys have written out the answer to all 20 problems. Okay, guys, look at number 4. If a particular variable appears in the numerator of an equation, is this variable directly proportional or inversely proportional to the resultant of the variable, to the resultant variable of the equation? Well, we just said that if it appears in the numerator, it is directly proportional. Okay, and guys, this is true for any and every equation we're going to see in the future. Okay. All right. Now, let us actually get to the mathematical problems. So let me show you guys what you guys are going to be doing. If you guys have a simple calculator next to you guys, even the calculator on your cell phones, this will be very easy to do. It's super, super easy. Basically, all you're doing is either multiplying or dividing depending on the situation that you're dealing with. Okay. And guys, don't just write out the answer here. Show me your work. Show me whether or not you're multiplying or dividing, and also write down whether the situation is directly proportional or inversely proportional. So let's just do a few examples together. Look at number 5. Number 5 says, imagine that you have an object and it's experiencing an acceleration of 5 meters per second squared. Now, an individual then triples the force being applied to the object. What is the object's new acceleration? Okay. So someone tell me what's going on here. If we're tripling the force, is force going up or force going down? What do y'all think? If we're tripling the force, that means we're doing what? Yeah. Tripling means we're going up. Exactly. So that means we need to be multiplying here. So as force goes up, then acceleration has to go up. So guys, if I triple my force, that means I must triple my acceleration. Okay. So here, you have to do 5 times 3, which means my new acceleration is 15 meters per second squared. Okay. So again, guys, in every problem, you need to show me whether or not you're multiplying or dividing. Okay. But that's not all, guys. You need to tell me what is the relationship between the two variables here. Are they directly proportional, inversely proportional? Remember, whenever we're dealing with force and acceleration, these two variables are directly proportional. So I'm just gonna put that here to represent, a direct proportionality. Okay, and that's the answer for that's the answer to number. That's the answer to number 5. Super easy. Again, guys, let us keep going. Again, guys, in this entire worksheet, it's up to you to know whether or not you're going to multiply and divide. And again, the reason why I'm starting out with this easy worksheet is because in the future, when we get to more complicated equations, where there's might be an x squared or a square root or something like that, you guys need to have this basic understanding of proportionalities when we get to that. Okay, so we're starting easy, but in the future, when we get to some more complicated proportionalities, I want you guys to have an understanding of this first. Okay, number 6 says, so imagine you have an object and it's experiencing an acceleration of 3.5 meters per second squared. So an individual then quadruples the force being applied to the object. What is the object's new acceleration? Okay. So what does quadruple means? Going up or going up, going down? Y'all should know what quadruple means. That's a term y'all should know. Yeah, going up. Thank you, Hannah. Because remember, guys, quadruple means you're increasing by a factor of 4. So all this is saying, guys, imagine you have some object and you have some force acting on it. What this is saying is if you quadruple the force, what's going to happen to the acceleration? Well, the acceleration gets quadrupled. Oh, my bad. I didn't mean to stop sharing that. Okay. So remember, guys, since force goes up, then acceleration needs to go up. So that means we need to multiply once again. So in order to figure out the new acceleration. So if the original acceleration is 3.5 meters per second squared, to figure out whatever the new acceleration is, if we quadruple the force, we need to multiply that by 4, which means we're going to quadruple our acceleration. And 3.5 times 4 is 14 meters per second squared. Okay, so when we quadruple our force, that means our acceleration quadruples to 14 meters per second squared. Okay. So hopefully that makes sense. Now, we're not done with number 6. We need to figure out what is this relationship here. Since we're dealing with force and acceleration, we know that we're dealing with a direct proportionality. Because again, force is in the numerator. Anytime, in any equation I give you guys in the future, anytime your variable appears in the numerator, it is directly proportional to the resultant. Anytime your variable appears in the denominator, it is inversely proportional to the resultant. That is true for every equation that I give you guys in the future. Okay. Moving right along. Again, guys, stop me if you guys have any questions. Number 7 says, imagine that an object is experiencing acceleration of 20 meters per second squared. An individual then takes another object that is half the mass of the first object and applies the same magnitude to the force of the object. What is the acceleration of the second object? Okay, so guys, notice what it said, guys. We took our mass and we halved the mass. So we halved the mass. That means our mass decreased. Our mass went down. So that means we need to come up here. We need to look at this situation right here. So as mass decreases, then that means acceleration must increase. So that means we need to multiply. We need to multiply. Okay, so as mass goes down, guys, acceleration has to go up. So we need to take 20. Now, guys, you guys should know what half means. Half means you decrease by a factor of 2. So we decrease by a factor of 2. That means we must multiply acceleration by a factor of 2. So that means our new acceleration is 40 meters per second squared. Okay. Okay. But that's not all for number 7. Not only do I want you guys to write out the answer, I want you guys to tell me whether or not our relationship is a direct proportionality or inverse proportionality. Notice now we're dealing with mass and acceleration. So since we're dealing with mass and acceleration, we're dealing with an inverse proportionality. That is relationship in this case right here because mass is in the denominator. Anytime you have an equation in this course, whatever's in the denominator is inversely proportional to the resultant. Any questions? Let us keep going. Look at number 8. Number 8 says an object is experiencing an acceleration of 12 meters per second squared. An individual then takes another object that is triple the mass of the first object and applies the same magnitude of force on that object. What is the acceleration of the second object? Okay, so guys, notice our mass tripled. Y'all know what tripled means. We just said tripled means mass increases. Okay. So what's going on here? Okay. So that means we're looking at this situation right here that as mass increases, then that means acceleration must decrease. So guess what we need to do here? We need to divide. Anytime our acceleration is decreasing, we need to divide. Okay, so going back to number 8. So if our acceleration is originally 12 meters per second, and so then we take another object and we triple the mass, but we apply the same force on that object, what is the acceleration of the second object? Okay, so here we need to divide by 3. Because again, so and guys, the reason why is because if our mass increases by a factor of 3, then our acceleration better decrease by a factor of 3. So 12 divided by 3 gives me 4 meters per second squared. So that's the number, that's the answer to number 8. Okay. Now guys, you guys have to write out, is the relationship an inverse proportionality or direct proportionality? So we're dealing with mass and acceleration here, so that's an inverse proportionality. Okay. All right, guys, let's keep going. I want to finish this first page. No, Braxton, you do not need to write the question. Braxton, the only thing you have to write, you have to show me whether or not you're multiplying or dividing the answer, and then tell me whether or not the relationship is inverse or direct. That's all you have to write. Okay, look at number 9. Number 9 says an object is experiencing an acceleration of 1.5 meters per second squared. An individual then increases the force being applied on the object by a factor of 9. What is the object's new acceleration? Okay, guys, so our force is increasing by a factor of 9. So that means we're in this situation right here with the top where force is going up, force is increasing. So if force increases, then acceleration better increase. So that means what we need to do, we need to multiply by a factor of 9 here. Okay. So number 9. So 1.5 times 9. That gives me 13.5 meters per second squared for my acceleration. Please be sure you include your units. Now, could someone in the chat box tell me, because hopefully you guys should get the point, we're dealing with the relationship between force and acceleration. Is that a direct proportionality or inverse proportionality? Thank you, Olivia. Thank you, Hannah, Jeanette, and Braxton. Direct. Okay, so it looks like y'all are getting this. All right. So if you guys are getting this, I can kind of speak. I can speed this up and just hear up and finish these last two. Okay. So number 10 says an object is experiencing an acceleration of 8 meters per second squared. An individual then reduces the force being applied to the object by a factor of 6. What is the object's new acceleration? Okay. So guys, so in this case right here, we clearly see that force is decreasing. Okay, so if force decreases, what happens to acceleration? Well, let's go up to the top. Remember, as force decreases, then acceleration must decrease. That means here we need to be dividing in order to get our answer. So guys, if force is decreased by a factor of 6, that means the acceleration better go down by a factor of 6. So that means 8 divided by 6 on number 10. This gives me 1.33 meters per second squared for my acceleration. Now, since we are dealing with the relationship between force and acceleration, here we have a direct proportionality here. Last one, guys, number 11. Number 11 says an object is experiencing an acceleration of 30 meters per second squared. An individual then takes another object that is double the mass of the first object and applies the same mass to the force to that object. What is the acceleration of the second object? So guys, in this particular example here, we're dealing with a situation where we doubled our mass. So since we've doubled our mass, okay, so we're up here. So as mass increases, acceleration better decrease. Okay, because we're dealing with an inverse proportionality here. So that means in order to find our answer, we need to divide. So guys, if my mass increased by a factor of 2, then that means my acceleration better decrease by a factor of 2. So I'm going to take 30 and divide it by 2, which gives me 15 meters per second squared for my new acceleration for the second object. And since we're dealing with the relationship between mass and acceleration, we're dealing with an inverse proportionality here. Again, because mass is in the denominator and acceleration is in the numerator. I'm sorry, excuse me. Mass is in the denominator and acceleration is our resultant. So, so these two are inversely proportional. Force is in the numerator, and so that means force and acceleration are directly proportional. So these two variables are directly proportional. These two variables are inversely proportional. Hey guys, you're just going to do the back by yourselves, and then once you're done, take a picture of both sides, and then you can turn it in. Braxton, you asked, how do I know if it's direct or inverse? Well, you read the question. So number 11, we were dealing with mass. So since we're dealing with mass, we know that the relationship between mass and acceleration, that's an inverse proportionality. If you read the question and you're dealing with force, like you're changing the force, then you know that's a direct proportionality, because the relationship between force and acceleration are inversely proportional. Are directly proportional. So in a nutshell, Braxton, if you read that you're dealing with force, it's always directly proportional. If you read that you're dealing with mass, it's always inversely proportional. Does that make sense? Okay. And again, and the reason why is because in our equation here for Newton's second law, force is in the numerator, mass is in the denominator. So since we're dealing with force in the numerator, force and acceleration are always directly proportional. Whatever we're dealing with in the denominator, mass and acceleration are always inversely proportional. And guys, that will be true for every equation that I give you in the future. Please remember that. It's super important. Whatever's in the numerator is directly proportional to the resultant, and whatever's in the denominator is inversely proportional to the resultant. Okay, guys. Um, 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 well, Dynasty, you asked where do Dynasty, you asked where do you have to turn it in? There's going to be a submission box that I'm going to make available to you guys. Once I make the submission box available, you can just turn it in.